All right, here's some questions from section 6.2 that deal with trigonometry and using trigonometry to solve. The first says solve the right triangle. Whenever they say that, I like just to write down all the sides and all the angles that I know, and I know that I'm going to have to fill in something for every one of those letters. Angle C is a right angle, so I know that's 90. Then they say A is 84 degrees 35 minutes. Oh, great. So 84. Now I'm going to convert that to decimal degrees right away. So I'll take the 35, the decimal or the minute portion of that, and divide it by 60. So 35 divided 60 is 0.583. So it'll be 84.583 degrees. If you have a calculator where you can put degree, minutes, seconds in, you can use that, but I typically just convert to decimal degrees. Then they say side A is 15.88. Okay, so I have three things. I got to find the other ones. One I can figure out for sure right away is angle B because I know they have to add up to 180. So 180 minus 84.583 minus 90 equals 5.417. Okay, so that's new one, something I figured out. And now I've got to figure out the sides. So let's plot things in here. So A, this side is 15.88, and this angle is 84.583. You can tell that the triangle is not drawn to square. It should be more like that, where this angle is 84.583. But I think it'll do for what we need. All right, why don't we start, and I don't know, let's start with side B. So if I want to know side B from this angle, that would be the adjacent side. And I know this side over here, which is the opposite side. So when I look at my ratios, the one that has an opposite and adjacent in it is tangent. So I'll use tangent of an angle is opposite over adjacent. Now I'll plug stuff in. The tangent of 84.583 is equal to the opposite side, 15.88, divided by the adjacent side, which I don't know. Now to solve for the adjacent side, I'm going to multiply both sides by adjacent, or that variable, so they cancel out here. And then I want to get adjacent by itself, so I'll divide both sides by tan of 84.583. So tan 80, I could have done that in a couple steps maybe. All right, so I have the adjacent is equal to 15.88 divided by the tangent of 84.583. Let's do that on my machine. 15.88 divide the tangent of 84.583. I'm getting 1.51. I think that might be correct. Let me, I think that's right. Let me just check to make sure I'm in the right mode. Sometimes I get in the wrong mode, and if you're in radians, that would be a bad thing. No, I'm in degrees, so it's got to be right. Okay, so that is for side, this one down here, side B. So side B is 1.51. Now to figure out side C, I could use Pythagoras because now I know two sides. So I could do that, or I could use a ratio again. Let's use this side here, and let's use this side here. So this is the opposite side, this is the hypotenuse, and that's opposite hypotenuse, that's that one. So sine of an angle is equal to the opposite side over the adjacent, or over the hypotenuse. So the sine of 84.583 is equal to the opposite side over the hypotenuse. I guess I could use the letter C down there for hypotenuse. And notice I'm going to have to do the same thing as I did here. I'm just going to rewrite it. Hypotenuse is 15.88 divided by the sine of 84.583. Now it looks the same, but here I'm using sine, over here I use tan, so I'll get a completely different answer. 15.88 divided by the sine of 84.583, go. 15.95, about. So that side C is 15.95. Now, might not be a bad idea to check, because you can do C squared equals A squared plus B squared, and you should come up with the same number. Let me just try it. A squared, so 15.88 squared plus B, what do I get for B? 1.51 squared. Let's see what that comes out to. 15.88 squared plus 1.51 squared, and then I have to take the square root of that. 15.95. And this one I think was a 0. This one was a 1. So it's fairly close. Fairly close. It's not exact, but I guess if I'd have used more decimal places for there, it might have been more exact. Anyway, that side is 15.95. All right, so that is that question. Sorry, I had somebody come by the office. Now here's another question. Suspension bridge, two main power towers of equal height. A visitor on a tour ship approaching the bridge estimates that the angle of elevation of one of the towers is 11. After sailing 420 feet closer, he estimates the angle to the same tower to be 60 degrees. So really having two towers is, we're not even talking about, it's just one, here's one tower. So there's a ship here, and it takes the reading at 11 degrees, then they go closer, and a reading there, now it's 60 degrees. So basically what I have is two triangles. And so I have this first one, looks like that, and then I have another one that looks like that. Okay? And a couple things to note on these is that the height of each of them is the same. This angle is 60 degrees, and this angle's 11 degrees. Now 421, unfortunately, is only the distance from this corner to here. That's 421 feet. And they're asking me for what the height of the thing is. Well, I don't know what this length is here. Maybe why don't we call it x? And if that's x, then from here to here, it's the same distance, has to be x as well. Well, let's mark this angle. This side over here is the opposite side, and this side is the adjacent side. Why don't we play with that for a bit? So that's the tangent ratio. So the tangent of 60 degrees is equal to the height divided by, I don't know that distance. Let's do the same thing for this one over here. This is my angle, so tangent of 11 degrees is equal to the height over, now it's the whole distance, so it's going to have to be x plus 421. Now both h's and x's are the same thing, so if what I could do is solve each equation for one of the letters and then make them equal. Let me show you what I mean. So let's solve this equation for h and this equation for h. So I'll take and I'll multiply both sides by an x. So h is going to be equal to x times by the tan of 60. And the tangent of 60 from that table that we've memorized is just root 3. Over here, I'll multiply both sides by x plus 421. X plus 421. And so I get h is equal to x plus 421 times the tangent of 11. That's not on my table. Don't have that memorized. Okay, let's figure out what the square root of 3 is. Okay, square root of 3. Whoops. Square root of 3. 1.73. So this would be 1.73x. And then on this side, let's figure out the tangent of 11. Tangent of 11. Tangent of 11, 0.194. So this would be x plus 421 times 0.194. Okay, equals h. Let's distribute that. So that'll be 0.194x plus 421 times 0.194, 81.7, call it, equals h. This is equal to h too. But this h and this h are the same thing. So whatever they're equal to also have to be the same. So 1.73x must be equal to 0.194x plus 81.7. I'll subtract 0.194x on both sides. And what will that be? 1.73 minus 0.194. 1.536 x equals 81.7. I'll continue up here, divide both sides by that. So I get 81.7 divided by that other answer. Go. Is that right? Yeah, that sounds about right. 53.2. 53.2. So that'll be, oh, well, that's just x. So that's this distance from there to there. But I want to know what h is. Oh, I could just plug it back in over into here then. So just take that number. So h I know is x times root 3. And if x is 53.2, just multiply that by root 3. Times the square root of 3, go. 92.1, I call it. So the height, 92.1. You could have taken and plugged that x value into here as well, and it should come out to the same answer. Hopefully that helps you with a couple of those questions.